All right, let's crush another Mtel question. This one says, given that x is greater than 1, which of the following expressions is equivalent to this expression right here? So we've got some negative exponents here. So it's important to understand what a negative exponent is. So x to the negative 1, what that means is 1 over x to the first. So basically when you see a negative exponent, it sort of turns it into a fraction. You can flip your expression and make the exponent positive. So x to the negative second is the same concept, except since it's squared, we'll have 1 over x to the second power. It's a pretty important exponent rule to understand here. So if we fill in what we have right here, just throw those in for the x to the negative 1, x to the negative 2, what we're going to get is 1 over x minus x divided by 1 over x squared minus x squared. Which is a pretty complicated expression. We've got fractions inside of fractions. This is going to be pretty difficult to deal with. Well, if we multiply the top and the bottom by x squared, then we'll get rid of these fractions because things are going to cancel. So let's just take a look at what that looks like. We're allowed to do this because if we multiply the top and the bottom of the fraction by the same thing, we didn't actually do anything to the fraction. We're basically just multiplying this fraction by 1, which doesn't change anything. So if we consider multiplying x squared into each term here, and then we'll do the same on the bottom, so just distributing this in, we're going to get a much simpler looking fraction. So we'll have, so x squared times 1 over x is x squared over x, and then we'll still have minus x times x squared, which is minus x to the third. X squared times 1 over x squared is x squared over x squared. And then x squared times x squared will have minus x to the fourth power. So using exponent rules, we can now simplify our fractions a little bit. So this is x to the first here. If you have two of the same bases divided by each other, you can just subtract the exponents. So x squared divided by x to the first is x to the 2 minus 1, or just x. And then we'll have minus x to the third. That doesn't change. And then on the bottom, x squared divided by x squared, something over itself is just 1. So those will just cancel out. And then we still have minus x to the fourth. Now we're going to do some factoring. So on top, we have a greatest common factor. Both of these things have an x. When we take out that x up top, what we're left is 1 minus x squared, because x to the third divided by x is just x squared. And on the bottom, we have the difference of two squares, which can be factored by taking the square root of the first minus the square root of the second. So the square root of 1 is 1 minus, and then the square root of the second is x squared. It'll be multiplied by 1 plus x squared. So the square root of both terms again. Instead, we're multiplying. That's how the difference of two squareds can be factored out. Hopefully you've seen something like that before. And then now we've got similar terms on the top and the bottom. We've got 1 minus x squared on the top and 1 minus x squared on the bottom, so we can actually just cancel those out. And what we're left with is x over 1 plus x squared, which is answer B.